study one of the most important concepts of data structure, stacks. What are stacks? Stack is an abstract data type which consists of data structure and set of primitive operations. Now the primitive operations are the operations which will be done on this stack when we need to add an element or to delete an element. A stack, to a more technical definition, is defined as a structure as an ordered collection of items where items are added to and removed from the end called top. So if you will see, this is a stack. It is representing similar to if we say it is a stack of books, or we can say stack of CDs, or any collection which is placed one above the other. Now stack here is represented in the form of an array. It can be represented in a form of a linked list, which we will see when we see the video for the linked list. Here it is represented in the form of an array. Here the top of the element, whatever we add, is added at the top, and whatever is removed from the top. Nothing can be removed from in between. So we can say a stack is a closed set of structure where you can just push in elements from the top and remove it from the top. So when we need to put any element into the stack, it is known as the function push, and when we need to remove an element from the stack, it is known by the function pop. It is similar to adding or removing elements in the array, but here the function push and the pop symbolizes that we are using a stack. Stack are ordered LIFO structure, which stands for last in, first out. That is, the element which enters last will be removed first. So it is a LIFO structure, and whatever we add it to the top, and after that we increment top by 1. So this is a diagrammatic representation of a stack. The stack operations are given below in the form of function. They are stack. This is a function which creates a new stack that is empty. It needs no parameters and returns an empty stack. Push item adds a new item to the top of the stack. It needs the item and returns nothing, as we are adding the item at the top of the stack. Pop removes the top item from the stack. It needs no parameter and returns the item. The stack is then modified. Stacks are linear data structures. This linear property, however, is not sufficient to discriminate a stack from other linear data structures. Now, what are the other linear data structures? The other linear data structure is an array. For example, an array is a sort of linear data structure. However, you can access any element in an array, which is not true for a stack, since you can deal with the element at its top. In an array, I can remove the element from middle. If I have an array like this, then you will see that I can add an element in the array over here, or I can remove an element from here. Whereas in case of my stack, nothing can be done. I can only remove or add an element from the last, or which is known as the top of my stack. One of the distinguishing characteristics of a stack, and that makes it useful, is the order in which elements come out of the stack. We will see how the applications are implemented using stack and using this unique property of a stack. Now, application of a stack, the first one is reversing the list. You will see how it is useful for reversing a list. Then the second one is a polish notation and evaluating the postfix expression. In this particular video, we will be seeing the reversing of the list using application of stack. Polish notation and evaluating the postfix expression will be following these videos. So let's see how reversing the list is done using a stack. Now, reversing the list, the application of a stack is it prints any given series of numbers, whether sorted or unsorted, in reverse order. As the stack follows the last in first out order, it gives the series of number in reverse order. Now let's see this example. Hash include stdio.h void main. I have a stack of 5 elements. Top is initialized to -1. While top is less than 5, I say top plus plus. Here we are not using any push or pop function. We're just using a simple array application to add the element at the top of the stack and then reverse it by printing it in the reverse order. We'll see how it is printed. So while top is less than 5, we say top plus plus, print, then enter the element for the stack and we enter the element to the top of the stack. While top is not equal to 0, the popped element is %d st top and top minus minus. If you will see, this is a normal array program for reversing a list, and this is the implementation of stack. So enter the elements for the stack. We've entered 10, 20, 30, 40 and 50. And when we are popping them out, it comes out in a reverse order because the number which comes in last moves out first because of the last in first out property. So 50, 40, 30, 20 and 10. So this is the first application of a stack for reversing the list of numbers. Now let's see how we do it with a push and a pop function. Now this is a menu driven program for the application of stack with the push, pop and a display function. So hash include stdio.h, hash include conio.h, hash define size is 10. So we're taking the size of a stack as 10. Void push integer, as push is a function which needs an element which needs to be added at the top of the stack. Pop just pops out the top element, and display will display all the elements into the stack which is remaining after the pop function. So int stack is the size and top is initialized to -1, which means that there are no elements in my stack. Void main int value choice CLR SAR is to clear the screen. While the choice is 1, we enter. So this is the menu which will be displayed. 1 is to push the element onto the stack, 2 is to pop, 3 is to display and 4 is to exit. You enter your choice and then depending on the choice we work on. Case 1, printf, enter the value to be inserted. We scan the value over here. Either you can scan the value in the push function or we're scanning the value over here and then passing the value to the push function. Pop will pop the element. Break is used so that after this case, no other case is executed for this choice. Display, break, exit to exit, and if other than 1, 2, 3, 4, we enter any other value, then it is a wrong selection. You have to try again. Now it comes to the push function. If the top is equal to size -1, that is I've exceeded my 10 elements, then it says stack is full, insertion is not possible, which is the condition for the stack overflow. So here, if I exceed the size, then it is a stack overflow condition. Else, top is incremented by here 1 over here. You will see it is incremented over here by 1. Stack of top is equal to value. If I've entered the value 10 over here, then the 10 will be stored over here. And printf, insertion is successful. It will go back till my while loop satisfied the condition of 1. And let's assume that I've added all the elements over here, and we assume my top is here, and we've added 10, 20, 30, 40 and 50. Now when I need to pop the elements, let's say 50 is already popped out. If top is equal to top -1, that is my stack is empty, and that condition is known as a stack underflow. When the size of my top is less than 0, then it is a stack underflow condition, and we say stack is empty, deletion is not possible. Else, printf deleted stack top, and this value, let's say 50 was over here, so over here 50 will be printed, and we say top is decremented by 1, so my top now comes over here with a value of 40 was here, right? And now let's say we don't want to say pop, we just want to display the elements from the stack, so we just say display. If top is equal to -1, that is stack is empty, and I is 1. Printf, the stack elements are, which was 40 over here, and we just print these elements like a normal array. So this is how the stack works with a menu driven program of push, pop and display. Thank you.